Hi, welcome to the mathcenter.com. In this video, we're going to look at an example that appeared in the Specimen paper 2020 exam, Statistics, A-level exam, paper 6, yeah? Subject code 9709/06. Yeah? 9709/06. We are looking at the CIE, the Cambridge exams. Yeah? Paper 6, Statistics. Yeah. Okay. Before we look at the question and discuss the solution, please share this video as much as you can. Give me a like and follow me on Facebook and YouTube for details of the courses that we provide online at the mathcenter.com. Please visit the website. There's lots and lots of information there. And the question itself, with the solution, I will provide it as a link below the video, so you have it with you. My aim here is to talk about the question and the general approach now that we have an exam 2 days away. Okay. Okay, I have summarized the information on the board. We have two random variables. L is normal with mean 1020 and variance 45 squared, and E is another random variable which is also normal, mean 2800 and a variance of 52 squared. Okay, L basically, if you read the question, it talks about the lifetime of a type of bulb. They call it long live, I think. Yeah. Okay, long live. That's why it's L, and I call it L. Okay, you can call it X and Y if you like. Okay, E is the other type of bulb, represents the lifetime of another type of bulb. I think it's called NLO or something. Yeah. Okay. So I'm calling it just so L and E. L for long life or long live, and E for NSA or NLO or something. Okay. Two types of bulbs. These represent their lifetimes. Okay. These represent lifetimes. So in part A, okay, before that, right, please read these questions very carefully because I have made it simpler for you because I've written out a probability statement, but for you have to read the question carefully and then write what I've written in part A. Yeah. So in part A, what has happened is they've taken 5 bulbs. Yeah. They've taken 5 bulbs randomly of the L type. Okay, of the L type. They've taken 5 bulbs randomly, and they ask you what's the probability that the total lifetime is bigger than or less than some number here. Okay, so they've taken 5 bulbs randomly of the L type, and they ask you what's the probability that the total lifetime, what's the operative word, total lifetime, is less than 5200. So I'm going to talk about the method of part A. So let me write the thing here again. Yeah, L1 plus L2 plus L3 plus L4 plus L5. That's the total lifetime of the 5 bulbs, less than 5200. I suggest you write, maybe introduce another variable, say y equals to L1 plus L2 all the way up to L5. So now you need to find the expected value of y. Okay, the expected value of y will be the expected value of L1 plus the expected value of L2 plus the expected value of all of those until L5. Expected value is what? Yeah, mu, right? 1020. So I have 5 times 1020. And then I also need the variance of y. Okay, the variance of y will be the variance of L1 plus the variance of L2 plus the variance of L3 and so on. So I have got 1, 2, 3, 4, 5 times 45 squared. Okay, because they gave me 45 squared as a variance. Yeah, 5 times. So you get these numbers out. I have the number somewhere. It's never mind. Those numbers are not important. Yeah, you can work it out yourself. Okay, then basically you're trying to find what is the probability that y is less than 5200. Is it 5200? Yes. So now you change your y to a z or a z if you like. Okay, and you have 5200. Excuse me, 5200. I'm going to call this. Okay, I'm going to call this mu y. I'm going to call this sigma squared y. So mu y over sigma y. Okay, you use your calculator, plug the number in here, plug the number in here, and then you look up your tables and you'll get your answers and you're done. Okay, so that's part A. So again, let me just remind you, when you do this question on the exam, remember the question given to you is in the form of is a worded problem. So you need to get rid of all the words and write it as a probability statement, and that's what is important. Yeah, it's pretty easy if you know how to do it. Yeah, in that sense. Okay, then when you're done with that, we want to look at, be careful, this is the variance of y. Okay, just looking at it again. Yeah, this is the variance of y, and so it's 5 times 45 squared. You'll get a number here. It's now I got the number. Then you just change it to a z or a z, sorry, and this is your standard normal variable, and then minus your mu y here over your sigma y, your standard deviation. Okay. Okay. So part B. Okay, part B of the problem. Here we are only taking one bulb. Yeah, one bulb of the E type and one bulb of the L type, and the question is, what is the probability that the lifetime of the E type, okay, the lifetime of the E type is at least as great as 3 times the L type? Okay, so when you read the question, this is what you need to come out with as a probability statement. Yeah, so let me write it here. Probability. Okay, so let me wear my glasses and I'll read you the question that is here. Find the probability that the lifetime of randomly chosen NLO, yeah, that's right, NLO bulb is at least 3 times. Is at least 3 times that of a randomly chosen long-lived bulb. So at least 3 times. So that's how you write this line here. Okay. Now, ideas generally how to work this problem. We always start with probability of E less than 3L bigger than or equal to 0. Move the variable from the right to the left. And now let W be equals to E minus 3L. Now, do the same thing again. The expected value of W will be the expected value of E, sorry, there are 2 E's here, okay, minus 3 times the expected value of L. You'll get a certain number here. So this will be mu W. Okay, so the expected value of W, okay, I'm calling this W, will be expected value of E. That's how much? 2800. I can do that here. This is 2800 minus 3 times the expected value 1020, and you'll get a certain number. Okay, and then we need the variance. Yeah, we need the variance of W. What's the variance of W? We are here now, right? This is W. Let me just put that in a little bracket. Not bracket, a little rectangle. The variance of W will be the variance of E plus 9 times the variance of L. Careful here. It's A squared variance of X. Remember, if Y equals to AX, the variance of Y is A squared variance of X. So now I have variance of E. Remember, there's a minus here. Don't let it bother you. It's minus 3 squared is plus 9. So what's variance of E? That's 52 squared. Okay. And plus 9 times the variance of L is how much? 45 squared. And you'll get some number here. Okay. So now we are ready to solve the last bit, which is pretty easy to do. Yeah. So now I'm just trying to write the last line. So I have probability. What am I trying to solve? Probability that W is bigger than or equals to 0. Right? Yeah. That's from here. So now I change my W to my Z, my standard normal variable. So I have Z greater than or equal to 0 minus mu W over sigma W. Use your calculator. You're going to get a number here. Look up your normal tables and you'll get your answer. Okay, so that's it with this problem. Thank you very much for watching. Share as much as you can. Follow me on Facebook and YouTube. And I'll see you next time. Thank you.